Welcome to today's class. Today we'll be solving questions on number bases, basically on additions and subtractions. We'll take a good number of questions that we'll be able to properly understand the concept of addition and subtractions under number bases. Now, you must take note of the fact that we have two methods, apart from using your calculator, obviously. You have two methods to solve additions and subtractions in number bases, but I'm going to start with the first method today, and I'm going to show us the second method, which is also going to lead us to another topic under number bases. Also, you must take note of the fact that we're going to be doing some multiplications, squaring and all under this topic today. Let's dive straight into it. The first example 1. Our question says 10110 plus 1111. All right, so in adding this, we have 10110 plus 1111. I wrote it from the right to the left so that I won't miss the placing. Remember, place values matter. So 0 plus 1, that's just 1. 1 plus 1, that's 2. But remember, sorry about this, I didn't add the bases. Okay, it's important that you add your bases. It's important because if you do not add your bases, it is assumed that you are talking in the natural base of numbers, and the natural base of numbers is base 10. This could as well be 10,110, and this could just be 1,111 if I do not indicate that I'm calculating in the base 2. All right, so take note of that for your own personal calculation. Where were we? All right, I said 1 plus 1, that's 2, but 2 cannot appear in base 2. It's the highest number that can appear in base 2 is 1. That's in binaries, we have zeros and ones. So what do we do when we have 1 plus 1 to be 2? We say 2 divided by 2, that's 1, remainder 0. So what do I do now? I write the 0 and I add this 1 to the next line. But I add 1 there, so I've got 1 plus 1 plus 1, that's 3. Right, so what do? 3 cannot appear in base 2, so I say 3 divided by 2, that's 1, remainder 1. I write the remainder 1 and I add this 1 to the next line. So now I have 1 plus 0 plus 1, which is 2. I already have that here, so I write 0, I write 1 in the next line. This is 2, I already have it here, so I write 0, I'll add the remaining 1 to the next line. So our answer is 100101. Moving on, let's take an example, a quick example on subtractions. We have quite a number of questions to solve today, so I'm just going to hurry up. We have 11011 is 2 minus 1101 is 2. 1 minus 1, that's 0. 1 minus 0, that's 1. 0 minus 1, we cannot do that. So what do? Borrow 1 from this end. All right, which actually we are borrowing 2 now. Okay, we subtract 1 from this end, which becomes 2 for this other side. So because we're calculating the base 2, all right, now we have 2 minus 1, which is 1. Now this place we have subtracted 1 from here, so we have to also borrow from the next line. So we borrow 1 from here too, so we have to, so now we have 2 minus 1, and that's 1. So we have 1110 is 2 as our answer. Let's quickly take another example. Example 3, 4, 3, 2, 1. We are calculating this in the base 7, and 1, 2, 3, 4 also in the base 7. And now we have a number, an unknown number here. I try to look for that number. So the question says if we are adding all of these and all of these give us this answer, 1, 4, 3, 2, 1. If this is our answer also in base 7, what is the missing number? What we're going to do is simple math. We first of all add this, add, and then subtract our answer from the answer here to get the missing number. So we're adding 4, 3, 2, 1 base 7 plus 1, 2, 3, 4 base 7. Since we're calculating the base 7, so 1 plus 4, that is 5, 2 plus 3 is 5, 3 plus 2 is 5, 4 plus 1 is 5. So we've got 5, 5, 5, 5 base 7 as the addition of these two. So we subtract these from the general answer to get the missing number. We have 1, 2, 3, 4, 1 base 7. We're calculating the base 7, and we have 5, 5, 5, 5 base 7. Okay, we're subtracting. We obviously cannot subtract 5 from 1, so we borrow 1. Yeah, we borrow 1 to this end. This one we are borrowing is 7. Is we adding 7 to this one because we are calculating base 7. If we're calculating in the base 2, we'll be adding 2. If we're calculating in base 10, we'll be adding 10. If we're calculating the base 4, and so on and so forth. So we've got 1 plus 7, which is 8. 8 minus 5, we have 3. We can obviously not subtract this from this. We can subtract 5 from 4. So we have to borrow 1, which is actually 7 too. So 7 plus 4, which is 11. 11 minus the one we borrowed. This arrow indicates that we borrowed something. 7 plus 4 is 11. Minus 1, that's 10. Minus 5, that's 5. Okay, we can subtract 5 from 3. So we have to borrow 1, which is 7. So 7 plus 3, 10. 10 minus 1, that's 9. 9 minus 5 is 4. Alright. And we say we borrow 1 too because we can subtract 5 from 2. So 7 plus 2 is 9. 9 minus the one we borrowed, which is indicated by the arrow, that's 8. 8 minus 5, that's 3. Finally, we have 1 minus the one we borrowed, 0. So our answer is 3, 4, 5, 3 base 7. Let's take another example. As I said, we have another method of solving this quite longer than this, or this, and a method we must understand. Usually we just use it to confirm our answers, and we must use that method in some other situations. Another example, this is example 4. We have to find the square of 111 base 2. That's basically saying 111 multiplied by 111. We're going to do this the way we usually do our multiplications, the normal way, alright? So 111 multiplied by 111, then base 2. So 1 multiplied by 1, that's 1. 1 times 1, 1. 1 times 1, 1. And the next one, 1 times 1, 1. 1 multiplied by 1, 1. By 1. Also 1, 1, 1. Alright. So here goes the addition. 1 plus nothing. We just write 1 there. 1 plus 1, that's 2. We cannot write 2 in base 2. So we say 2 divided by 2. That's 1 remainder 0. Write it here, 0. Write the remainder 0. Remember, we are writing the remainder and you're adding the original answer to the next line. So we have 1 plus 1 plus 1, which is 4. So we have 4 divided by 2. We can write 4 too in base 2. So we have 4 divided by 2. We have 2, remainder 0. Write the remainder. We add 2 to the next line. 2 plus 1 plus 1, that's 4. We already have it here, so write 0 here. And add 2 to this line. So we have 2 plus 1, which is 3. 3 divided by 2. That's 1 remainder 1. Because 2 we divide 3 once, I'll let you the remainder 1. So write the remainder here and write this. Since there's not no other line, we'll just write this here. So our answer will be 11000 base 2. So at the end of this class, I'm going to give you guys an assignment, and if you do not get it, you can reach out to me. My link will be in the description. Let's take one final example. 23 is x plus 101 base x is equal to 130 base x. We have to find the base. What is x? What is this base? What do we do? Let's simply add it. So we have 23 is x, and we have 101 base x. We're adding 3 plus 1 is 4. Our job is to find out that number. That's how we divide 4 by. That will give me a remainder of 0, because recall this 0 here is the remainder. So what number is that? It's 4, because 4 divided by 4 is 1, remainder 0. It is only under this condition that we can have a remainder of 0. We have 0, we add 1 to the next line. You see 2 plus 1 plus 0, that's 3 and 1. So it fits our answer here. The base is 4. X is equal to 4. Alright, I hope you understood that. So let's take the assignment before we go. The following. Okay, you have to find the missing number here. Find the missing number. You don't know what that is. Also, find the square of these two numbers as subtracted. Alright, thank you very much for coming to today's class. I hope you enjoyed the class. See you in the next class. Bye bye.